Hello, good afternoon, and welcome to our 19th annual exhibit of hydrogen and fuel cell technology. We invite all of you to sit down and have a drink. We're serving coffee, tea, and other beverages. You're welcome to have a seat and relax and enjoy some information about the fuel cell industry. It is a complicated industry. There's a lot involved in fuel cell technologies. We are happy this time around to present what I like to refer to as the godfather of fuel processing, the author of the only book dedicated to the subject of fuel processing, and he is Professor Dr. Gunther Kolb. He is head of energy technology and catalysis at the Institut for Mikrotechnology in Mainz. Please welcome with me Professor Dr. Gunther Kolb.
Hello.
Hello, I hope you don't mind the reference to my favorite movie. For insiders, of course, the Institute for Microtechnology and Catalysis is a very important issue here, but perhaps before we get into the technology you want to discuss today, could you give us an idea of what your institute does and what you do at that institute in Mainz?
Yeah, we are a publicly funded research institute owned by the federal state of Rhineland-Palatinate, and we work on different areas of microtechnology, medical lab-on-a-chip applications, precision engineering, developing chemical reactors for the chemical industry to do process intensification, but also on energy technology, which is my department. And there we both cover the field of hydrogen and fuel cells, hydrogen production for fuel cells. We will talk much more in detail about that in a second, but also on other applications in the field of production of renewable fuels, such as biodiesel, integrated biorefinery concepts, and mobile heat and air conditioning systems as well.
Now, to bring this down to the basics, of course, we've got all sorts of gases that people use as a form of energy. There's natural gas. There, you can go through the list, the biogas. But the hydrocarbons, they always have hydrogen in them. And the problem is, if you want to run specific hydrogen fuel cell technologies like the PEM cell, you need hydrogen. To do that, you need a unit, and you need, this is where your expertise is, a catalyst. Yeah. So you actually create your own catalysts. You're optimizing your own catalysts. How did you get involved in this process of developing catalysts for fuel treatment?
Basically, one of the main reasons is that when I came to the institute, there was not so much knowledge about that. But I'm a catalyst guy. I was working for a catalyst supplier before. And that brought us into the field originally, yeah? And now we have built up big knowledge about catalyst development, and especially how to engineer and how to make catalysts durable for industrial processes, yeah? To make them long-term stable. So basically we make catalysts mostly for fuel processing, for producing hydrogen out of all kinds of fuels. You mentioned that, starting from methanol over polyalcohols, gasoline, diesel, LPG, natural gas. We can handle all these kind of fuels. So if you have a fuel I haven't heard from, we will solve that problem for you, don't worry. Yeah, we have a lot of test rigs running 24 hours and 7 days per week for catalyst testing, for catalyst durability testing. So this is one of our big strengths, which is also a difference to our competitive institutes, our know-how about catalyst technology.
There's a lot of issues that we'll have to go through here. There are, for instance, applications for mobile use, stationary applications, but there's one central question, which is always cost. And if you can mass produce the product that you create, that can reduce costs. So how do you get the catalyst cheaply into these reactors? How do you approach that issue?
Yeah, the aspect of mass production is something we take care of for several years now. We have developed a system. We will maybe talk a little bit more in detail in a few minutes. which is a LPG fuel processor for a LPG-driven fuel cell system for recreational vehicles. This fuel processor, how it looked like 5 years ago, I have brought with me. So you see, this one is quite small. We make much bigger reactors nowadays as well. But the question is, these are plate heat exchangers with catalysts on it, how to get that produced cheaply. And there are several steps which are involved in such a production. So what we are working on this year now very hard is to get a tool produced and running which creates embossed modules shaped by punching and cutting and bending, which are then coated with a catalyst by a screen printing technology. This is another core technology we have developed. It cost us a lot of man-years to get it running, but we have a screen printing technology to get the catalyst into the microchannels which are in the plates inside there. Yeah? And then you get these modules out, you put the catalyst onto it, you make a staple like that, and you weld it with a laser. So are the 3 production steps, each of them cheap, enough to get a reasonable price.
Now, whenever we talk about hydrogen, there are significant issues of purity of hydrogen. If we're running, for instance, PEM technology, the PEM technologies, they really require pure hydrogen. There are other uses of hydrogen, of course, but our topic today is microstructured devices for decentralized hydrogen production. So if we take a smaller scale issue, that is an automotive application, that is a relatively small looking unit to me. Does it address specifically, are there different units depending on the purity of hydrogen you want out of it? Can you deal directly with the PEM cell? And are there cheaper solutions if it doesn't matter whether the hydrogen is 99.99999% pure? What would you think?
Yeah, depending on the PEM technology, we can handle all the different steps which are required to get clean enough hydrogen, I would say, out of the fuel. You can see some of our reactors at our booth, and you can see also the complete system of the company Truma, which is opposite to our booth. So this is a fuel processor for a high temperature PEM fuel cell. It still can tolerate let's say about 1% of carbon monoxide at least. Nevertheless, there are still 5 chemical reactions taking place in that small fuel processor, combined in the reactors by this heat exchanger technology. So we can also do the next step then, going from 1% down to something like 10 ppm, which is reasonable for reformate-tolerant PEM fuel cells as well. So we have technology there, we have catalysts, and we have reactor design. And not only for such a small scale, you will see that at our booth, but also for kilowatt scale. And another important issue is also, I believe, methanol is a quite interesting fuel for decentralized power generation of the bigger scale. So we have developed a methanol catalyst, which is highly active and perfectly suits to these plate heat exchangers. And our aim and our target is now for the next years to build such a methanol reforming reactor for a megawatt scale with our microchannel technology. So that reactor will have a size like that, not more than that for a megawatt, but there are then thousands and thousands of small channels inside. And the micro is inside and not outside. Yeah.
I should mention that if there are questions from the audience, we will be able to address a few of them here. Certainly, when I think of the applications, we're always facing one issue when we talk about mobile applications for hydrogen, and that is the energy density issue. Hydrogen, either you pressurize it a lot, or you can't carry much hydrogen with you if you're driving a car. And pressurization itself is a loss of energy. If you want to carry a 700 bar pressure tank, you may lose 60% of the energy doing that. Are you developing any of these reactors such that they can be used mobile? What I mean is your actual energy tank would be methanol or propane, something like that, and you actually use this as a reforming technology on board in the vehicle? Or are you thinking of developing a decentralized fueling station, for example, so that you could tank the car with hydrogen more often along a highway? Where are your thoughts going there?
Both directions. The one is using the high energy density of the fuel on board, which we can do nowadays already. The system of Vega of the company Truma is commercially available already. So we are working together with Volvo on such an auxiliary power unit for trucks, which is fueled by diesel then. We are working with the aerospace industry on different applications in that area to make power generation systems, APUs for planes. But we also work on that methanol system, which could be an ideal solution for hydrogen filling stations, not to transport compressed hydrogen to the filling station, but rather using methanol. As I said, it's a fuel you can easily reform, and I think that's the right solution for other applications then. Yeah?
Mm-hmm. When we address questions of efficiency, and everyone always worries about this efficiency, the efficient use of energy sources, in this case we are using one energy source to power up another. Hydrogen is the energy carrier in that sense. And people will often say, well, how efficient is the total system? With your fuel reforming, is it more effective, more efficient if you go large scale? That is, if you have a centralized plant and you deal with large quantities of gases and create large quantities of hydrogen, does it become more efficient if you deal in volume, or do the smaller devices also offer efficiency that would be appropriate for an automobile?
Of course, the efficiency goes up for a combustion engine as for such a fuel cell system. Nevertheless, that small system here has a power output of 250 watts. We reach 20% efficiency. If you do the same power generation with a combustion engine, you will be in the range from 5 to 7%. This is 4 times higher.
Wow.
Now, that helps to reduce the consumption. Yeah? On the other hand, if you build bigger systems, you also can reach a much higher efficiency with a fuel cell system compared to a regular system, especially as everybody knows, if you use the off heat of the process for residential applications, you can extract almost all the energy out of the system.
Dr. Kolb, when you look at the potential applications, you also have to do this in view of the development of the fuel cell industry. Where's the demand? Who's going to be your next customer? Are you satisfied with the way the fuel cell industry is developing? That is, are you waiting impatiently for the next mobile application? Is there enough interest generated in decentralized fuel structure? I certainly know that here we always face this issue of, yes, we can build a car, but where can we tank it? And we do need to solve this decentralized structure of providing hydrogen. So where are we now? In a state of frustration, or is there hope ahead?
There should be a little bit more patience, generally, because I believe jumping from batteries to hydrogen back and forth is not the right solution. One should follow up both routes permanently without hyping too much. That is one thing I really would like to criticize. The other thing is people have to change their attitude. If you want to have a car which has exactly the same performance as it has now with a combustion engine, and you want to have new and clean technology, that will not work from the beginning. Yeah? But everybody tries to do that. I think this is a wrong way. You have a problem with platinum cost. Why? Because the car has 100 kilowatts. If the car would have 20 kilowatts, okay, it's not the same car, but maybe more affordable. So we should find niche applications and go into the market and not try to get exactly the same out with a completely different technology from the first day. That was also a big mistake when the fuel processing was started. Everybody tries to get a tried to get a fuel processor maybe 15 years ago, starting up in 2 minutes. You cannot start up a chemical reactor up to 800 degrees in 2 minutes without having a huge bunch of problems. So doing the first step and then the second and not the third step is the first.
Certainly makes sense to me. Within those niche applications, do these manufacturers come to you and address questions to do, particularly when they're developing something and they need a local supply? We know at this fair that there are a number of successful niche applications, but then again you hear people actually trucking hydrogen to an area where they then tank up their, let's say, forklift trucks, which operate on hydrogen and batteries. Are people addressing enough questions to you, and is the cooperation working well?
There are people which do that, others don't. And there should always be a full-scale life cycle analysis of such a technical solution be done at the very beginning to see if it's reasonable what is done. Yeah, and as I said before, transporting fuels such as methanol to a decentralized production plant might be a better solution in some cases. But there should always be a fair analysis done to not create more unsustainable stuff than is necessary.
You mentioned the word sustainability. Again, this is more of a philosophical question, but as the fossil fuels slowly decline, the amount available, we're still left with biogas of various types, of course.
And biofuels. Also liquid fuels.
Yeah.
Bioethanol.
Does that make your job easier?
I would say no. It's as difficult to work with biodiesel, or even worse than to work with regular diesel. And biogas also has impurities inside, so it needs to be addressed and carefully analyzed in each case. Yes.
Okay. Of course, before we finish, we shouldn't fail to mention what things you have operating right now, what tested equipment, I should say, fueling components. So these have all been up and running. This unit you have in your hand, it's been
commercialized.
It's been commercialized. This is very significant because there's not many commercialized products. So this is a commercialized unit. How many have you produced so far?
So that is something which started a few months ago, the commercial availability, and it's in the range of 4 digits for the first year. So
those are still very significant numbers. Wonderful. I would like to remind you that the booth is B72. I've lost my bearings here. It's behind us, isn't it? In this direction here. And for more technical details, you should return to Professor Dr. Gunther Kolb, who is the head of energy technology and catalysis, and as I mentioned at the beginning, the godfather of fuel processing with a lot of expertise, particularly the Institut for Microtechnology in Mainz, and they're specialists in developing their own catalysts. I find fascinating, very important. We're happy to have you here. Hope to see you back next year. It's been a pleasure talking to you. Thank you very much.